All right, so we are going to be doing domain of composite functions today. So the majority of today is going to be finding the composite, which is what we did yesterday. So the first half is kind of the steps from yesterday, and then the second half is going to be to find the domain like we did at the very beginning of the year with the square roots and the fractions. You remember that poster right there? Okay. Now there are technically two methods for domain. This method, way more confusing. You can see it even has more words. So we are focusing on method 1. All right, so step 1, find the composite function. That's what we did yesterday. Step 2, we're going to use the domain rules to find the domain of the composite function. That's what we did at the very beginning of the year. Step 3, you also have to check the inside function. All right, so you have to check the inside function to include those in your final answer. All right, so we're going to let f be x squared plus 2x minus 1. We're going to let g be 1 over x minus 2, and we're going to let h be the square root of 3x. And we're going to find the domain of each of these composite functions. So to kind of make this a little bit quicker, I'm putting the answers already on here because these were the composite functions we found yesterday on page 3. Okay, so we already found the composite functions. All right, and I do have other examples where we're going to go from start to finish, but I want to kind of focus on how you do the domain for a little bit. All right, so this is the stuff I have written down. This is what we did yesterday. So to kind of remind you, where is it? Oh, right here. All right, so yesterday here, you see how the functions are the same? And then this was f of g. This is the first one we're going to do. I don't know why that's gone, but whatever. And then the f of h and the h of f. All right, so all of my answers, if you need the answers, they're coming from this page right here. It's just to shorten the steps a little bit. Does that make sense? Okay. All right, so on 12, your first step, you're going to rewrite this and you're going to replace g, right? That's always your first step. And you're going to put that into f and you're going to get your composite, which is what we did yesterday. And we ended up with this answer that I have in purple. So this is the answer that I got from yesterday. Once you get your composite function, now we got to do the domain part, which is the new part for today. So from my composite function, do I have, so here's my composite. Do I have any square roots? No. Do I have any fractions? Yes. So I'm going to take the bottom of the fraction, which is x minus 2. And what's the rule for fractions? Cannot be 0. So x can't be 2. So that's one of my domain restrictions. Then I got to look at the inside function. Do you have another domain restriction?
Yes, kind of, but it's the same.
It's the same thing, right? It's still a fraction, but you're going to get that same domain restriction. So this is the only domain restriction that I have on that example. X can't be 2. And it doesn't specify, but in interval notation, I would go from negative infinity all the way to 2, and then 2 to infinity. If it doesn't specify, you do not have to put in interval notation, but it is a good idea to know, make sure you can go from here to here. All right, so if you can't see that this domain restriction is the same as this interval notation, I would practice it. Because if it was multiple choice, I might give it to you that way. And you have to know it's the same thing. All right, so let's look at 13. All right, so same thing. This problem came from yesterday. So we replaced f of x with x squared plus 2x minus 1. We put that in the g function and simplified, and we got this fella right here. So this was my composite function. Do you have a fraction or a square root? We have a fraction, and the bottom of the fraction cannot be 0. Yes. So if you have a squared, and you are trying to solve, what do you do? Factor. So what multiplies to give me negative 3 but adds to give me 2? Yes. So x plus 3, x minus 1. So my two restrictions are going to be? Negative 3 and 1. Yep. And then we need to check the inside. Does the inside have a fraction or a square root?
No.
Nope. So inside we're good. So these are the only domain restrictions. And if you wanted to write that in interval notation, you would go from negative infinity to negative 3, negative 3 to 1, and 1 to infinity. So all of those restrictions there are vertical asymptotes because they cannot equal. And they're coming from the bottom. When you set the bottom equal to 0, that is a vertical asymptote. All right, so these answers are the same thing. This is interval notation. If it doesn't specify, I don't care how you write it, but you do need to know both ways. All right, next one. So once again, same thing from yesterday. We took the inside, we replaced it with the square root of 3x, we put it into f and we simplified, and we got this fella right here. Do you have any fractions or square roots? We've got square roots. For the square roots, I only care about the inside. So I do not care about anything on the outside. I don't care about the 3x, the 2, or the minus 1. All I care about is the 3x.
Greater than or equal to 0.
Yep, so greater than or equal to 0. So when you divide by 3, you get x is greater than or equal to 0. So that's my domain restriction. When I consider the inside, it's the same thing. It is a square root, but it's the exact same square root as in my function, so it gives me the exact same domain restriction. And in interval notation, we would go from 0 to infinity because it is greater than 0. With a bracket because it or equal to. Alrighty, and then my last one from yesterday. Is this guy right here. So I replaced f of x with x squared plus 2x minus 1. Put that in h, and I simplified it, and I got this fella right here. So fractions are square roots. Square roots. And so the rule for the square roots is that everything on the inside, the 3x squared plus 6x minus 3 has to be greater than or equal to 0. Okay, on this one, you actually are not factorable. Because there are no two numbers that will multiply to give you negative 9, but add to give you 6. All right, the negative is throwing us. So it is a not factorable problem, which is kind of annoying because if you can't factor, what do you have to do? No, I mean, it is a different method. What's besides factoring? Quadratic what? Yeah, but it's still, I don't think that still wouldn't make it factorable. What?
Negative 1 times negative. Oh, wait, no.
Because negative 1 times negative 1 would give you positive 1, not negative 1. And then negative 1 times positive 1 would give you 0, not 2. 1 times 1 would give you positive 1, not negative 1. Does that make sense? Like, it's like we're just slightly wrong there. Like, we're just a negative away of being able to factor, which is super annoying. And so this one is a quadratic formula question, which I want you to work on some homework today. So for the sake of time, we're gonna skip it, if that's okay.
Is there any on the homework that are quadratic?
I guess that's a good point. Let me check. Let me borrow this for a second. I don't think so. I guess if there is one, I should do it.
What? Dude, I forgot the quadratic formula.
You forgot it. Maybe we should do it.
No, that's a me problem.
Okay. Yeah.
No, there's none on the homework that has quadratic formula. I don't think so. Here, we'll do it real fast. Quadratic formula is negative b plus or minus square root b squared minus 4ac all over 2a. So the a is 3, the b is 6, the c is negative 3. So then when you put this in here, negative 6 plus or minus the square root of 6 squared minus 4 times 3 times negative 3 all over 2 times 3. And this would be a calculator question. I'm not going to make you do that. without a calculator. And so you would type all that in. You can't type a plus sign in though, so you would have to type it in once with a plus and once with a minus. Does that make sense? So you would type it all in, and it would give you the answers of 0.414 and negative 2.414. So I'm going to put those on my number line. And then just like we did in the beginning of the year, because I want to figure out which one of these intervals is going to work and be greater than or equal to 0. So remember when we talked about inequalities, we had to make a number line. What would be a good test number? 0, which is right here. And when you plug 0 into this guy right here, so when you plug 0 in here, you get negative 3. Is negative 3 greater than 0? No. So which way should your arrows go? Outward. All right, not towards 0, outward. So my arrows would go this way. And so then your domain is going to go from negative infinity to negative 2.414 bracket, and then from 0.414 to infinity. All right, I'm not going to give you a quadratic formula on the test. It takes too much time to do. And you don't have one on the homework. But you might have one, and we're going to have another one kind of like this where you have to do a test number. So you might have something with a test number. Okay, so we did the composites yesterday. We just talked about domains. So these next couple examples, we're going to go from start to finish. We're going to do the whole entire problem. Okay? So first step is we got to find the composite. So I'm going to put parentheses around f of x. And I'm going to replace f of x with whatever it is, which is 1 over x plus 3. The g is still on the outside. All right, so first step, replace the inside function. We're going to need it later. It makes it better to look at this way too. So now I'm going to put this guy into the g function. So g starts with 2 over 1 over x plus 3. And then we're going to simplify. What do you do when you have fractions and fractions? We're going to multiply. We're going to change flip. So we're going to keep the 2, change the sign to multiplication, and flip that guy around. So 2 times x plus 3 over 1. So my composite function is going to be 2x plus 6. All right, that's what we did yesterday. Now we're going to find the domain. So from your composite, any fractions or roots? No. So no domain restrictions here. What about from the inside? Yes, the bottom, which is x plus 3, cannot equal 0. So x cannot equal negative 3. And if you want to leave it like that, you can, or you can put it in interval notation.
Wait, so the g of 1 over x plus 3 is where you get the domain?
You have to check 2 places for the domain. So you check your composite, but nothing there, and then you check your inside function. Nope. All right, let's do another one. So I'm going to put parentheses around g of x. And I'm going to replace that inside function, which is the square root of 2x plus, whoa, what happened? 2x plus 3. And so we are going to put this guy into the f function right there, in for the x spot. So the 4 over square root of 2x plus 3 squared plus 1. So what happens with the square root and the square?
Cancel.
It cancels. So I get 4 over 2x plus 3 plus 1, which is 4. And what can you divide all 3 of your things by? 2. So my composite function is 2 over x plus 2. No, because of the plus x. So all you can do is, because if you're canceling, you have to cancel it out of every single thing. right, so I've got my composite function. Now I check my domain. So from my composite, fractions or roots? Fractions. And so from the bottom, x cannot be 0, which means x cannot be -2. All right, and then I'm going to come over here and I'm going to check the inside, which is going to give you another domain restriction because it's square root. So 2x plus 3 has to be what? Greater than or equal to 0. So you minus 3, divide by 2. And so I also get x has to be greater than or equal to -3/2. When you get two domain restrictions, sometimes drawing a number line becomes helpful to kind of figure out what's going on. Oops, I put those in the wrong spot. All right, so on your number line, -2 is going to go here. -3/2 is going to go here. All right, if I want to definitely be greater than -3/2, none of this is going to matter. So really, this guy right here is the only domain that I need because your answer would go from -3/2 to infinity. Right, because if you are greater than -3/2, you're never going to be at -2. So we don't actually care. It becomes irrelevant. All right. Put parentheses around g of x. What does g of x equal?
Square root of 9 minus x squared.
All right, so we're going to put that into the f spot right here. So I've got the square root of 9 minus x squared, squared minus 9. What happens with your square root and your square?
Cancel.
It cancels. So I get 9 minus x squared minus 9, which cancels the 9, and I just have -x squared. So does my composite have any domain restrictions?
No.
Nope. What about the inside function?
Yes.
Yes, bless you. So, bless you. 9 minus x squared has to be greater than or equal to 0. All right, with the inequality, when you have the squared, you kind of have to ignore the inequality because when you square root and things like that, the inequality starts not mattering anymore, and we have to draw a number line anyways. All right, so I'm going to solve this out for x. So I'm going to minus 9 divide by a negative, which flips it. But when you square root here, now my sign's really going to stop mattering. And I know my x's are going to be plus or minus 3. All right, but I got to figure out which interval is correct. So I have -3 and 3, and I have to figure out if my arrow's going to go out or are they going to go in. Which interval is going to give me greater than or equal to 0? So 0 is a good test number. It's right smack here in the middle. I'm going to go back up to my original. When I plug 0 in, what's 9 minus 0? 9. Is that greater than 0? Yes. And so my interval would be toward the 0. So my domain is going to be from -3, 3. So see, sometimes with the domain, it does help to draw a number line and write it in interval notation. Sometimes on some of the easier ones, you can get away with just writing it as like x can't be -3. All right, 2 more and then we're done. Getting close. All right, g of x is going to be
X squared plus 4.
x squared plus 4. And we're going to put that into
X.
the x spot there. So I have the square root, x squared plus 4 plus 1, which is going to simplify to be
Square root of x squared.
plus 5. So this is my composite. All right, do you have fractions or roots? We've got roots, and so we're going to take the inside greater than or equal to 0. And we're going to solve it out. So first I'm going to minus the 5. And square root, and once again, when you square root, it kind of makes this greater than sign start getting weird and not mattering. But on this one, what is the square root of -5? Imaginary. So does it have any restrictions? No. What about the inside? Will the inside function give me any restrictions?
No.
No. So if there's no restrictions, what's my domain?
All of them.
All real numbers. Or you can say from -infinity to infinity. All right, and my last one. Which on this last one here, this is supposed to be a plus sign. And I wanted to talk about the fractions real fast and the domains if you're adding two functions. So most of today was composites. We put a function in a function, but remember yesterday we also added and subtracted and multiplied and divided, and on your homework quiz you did that. So if I wanted to come up with the function f plus g, that's x over x plus 2 plus 3x plus 2. So this is my function. It's not all in one giant fraction, but it doesn't matter because when you're doing your domain restrictions, they are just going to come from the bottom of your fractions. All right, so whatever's in the bottom. So on this one here, we're going to say x plus 2 can't be 0. And this denominator doesn't have anything. It's an understood 1, so there's no restrictions coming from that denominator. So you just get a restriction from every single denominator. Does that make sense? So this restriction would be x can't be -2. And this is not a composite, so there's not an inside function I have to check. So when you're doing the pluses and the minuses and the multiplying and things like that, you just find your new function and check the domain of it. There's no inside function that got put in that you have to also check. That's only for composites. Does that make sense? Okay, so I just wanted to make sure that you know the difference between the pluses and the minuses versus the composites that we did for the majority of today. Okay, on your homework,
When it says like f times h of x, is that the same thing as we have been doing with like the composites? Or is that something else? On like 5.
That guy? The f of, yes, that's a composite. So this h is your inside. Yep. Now on 8 though, this guy here, because it's not an open circle, this is a regular multiplying. So this number 8 is not a composite. You would just multiply the f function times the g function. So that one's just multiplying. But like 5 and 6, those are composites. And then on the front here, you've got A, B, and C. So at the top, A is f of g, B is g of f, and C is f of f. And then it has you put the domain down here. I think I probably put my answer key all in interval notation. But if, like I said, if you have it in the other notation, as long as you can match it up and be like, oh yeah, that's the same thing, I'm good with that. So on A for f of g, all right, so A is right here, f of g. G is x squared minus 1. So I'm going to put that guy in place of the f. So I have the square root of x squared minus 1 plus 1, which gives me the square root of x squared, or x. All right, so here's my composite. Any domain restrictions? Nope. What about the inside? Nope. So if there's no domain restrictions, your domain's all real numbers. All right, so now we're going to check B. So B is g of f. F is the square root of x plus 1. All right, so g of f is the next one. And so into the g function, I'm going to put this. So I'm going to put the square root of x plus 1 squared minus 1. What happens with the square root and the square?
Cancel.
They cancel. And you get x plus 1 minus 1, which is just
X.
x. All right. Any domain restrictions?
No.
Nope. What about the inside?
Yes.
Yes. So the inside is x plus 1 has to be greater than or equal to 0. So x has to be greater than or equal to negative 1. And then C, which is f of f. Oops. So the f function is the square root of x plus 1. So we're going to put the square root of x plus 1 into the square root of x plus 1. So we're going to start off with the square root of x plus 1, and then plus 1. And there's really not a whole lot we can do with this guy. Now, I do know that inside the square root here, your domain is going to be greater than or equal to negative 1, because inside that square root, that's going to be your domain, and inside this square root, that's going to be your domain. Does that make sense? And then inside the big square root, you'll get an imaginary number because you'll minus 1. And the square root's never going to be negative 1. Does that make sense? So this one here is not going to give you anything. So this is your domain.
Just don't say anything.
Yeah, you don't say anything about this one. So just this one that's coming from inside the other two square roots, the smaller one. All right, so that's kind of how you do that one. So you've got 3 more of those guys, and then you've got like a handful on the back. All right, practicing domain. And then you have another domain practice worksheet for extra credit if you want to do it, great. And if you're like, nope, I don't want to do that, that's fine too. But it's due Monday. And don't forget that grades are due for me on Wednesday. Not today, a week from today.